Assalamu alaikum students, unit number 4 and exercise number 4.3 we will start today. But before starting this exercise 4.3, there are some standard definitions and laws that will be used in this exercise. And for this is surds and its application. What is surd? An irrational radical with a rational radicand is called a surd. An irrational radicand with rational radicand is called a surd. What is this? An irrational radical with rational radicand is called surd. First, we should know what is radical and what is radicand. If I am writing this expression, I have already explained you in unit number 2. If it is written as square root 7 with index 3, it means here we have three things to discuss. First one, 7. What is 7? Is radicand. It means the number inside the square root sign is the radicand. And what is this sign mean? It is radical sign. And where 3 is the index. I hope you understand this, because we already seen this in the unit number 2, where we are studying about exponential equation, exponential expression and radical expression. So an irrational radical with rational radicand is called a surd. Hence the radical square root of a with the index n is a surd if a is rational, the result square root of a is irrational. Okay, for example, square root 3, square root 2 over 5, square root 7, square root 10 with index 4 are surds, but square root pi and square root 2 plus square root 5 are not surd, because pi and 2 plus square root 17 are not rational. It means for a surd it is compulsory that the radicand should be rational and irrational radical, and radical sign should be irrational. The radicand, it means number inside should be a rational number. 17, 2 over 5 is rational, 7 is rational, 10 is rational, square root 3 is rational, but it should not be an irrational. In this example, square root pi, pi is an irrational number, so it will not be a surd. Square root 17, again it is an irrational number, so they are not the surd. Note that the surd square root of a with index n is called the surd index or the order of the surd, and the rational number a is called the radicand square root of 7, cube root of 7. Here, when the power of the square root sign is 3, we say that cube root of 7 is third order surd. When its power is 4, we'll say that fourth order surd. When its power is 5, we'll say 5 order surd. So the index is called the order of that surd. Every surd is an irrational number. Not every surd is an irrational number, but every irrational number is not a surd. The surd cube root of 5 is an irrational number, but the irrational number square root pi is not a surd. So this is the example that every surd is an irrational number. See this, square root 3 irrational, square root 10 with index 4 irrational, but every irrational number cannot be a surd, because the reason is cube root of 3 is an irrational number, but the irrational number square root pi is not a surd. Now some more theory about the surds, and on the next page it is operations on surds. Addition and subtraction of surds as we add numbers. Similarly, surds, that is surds having same irrational factors, can be added or subtracted into a single term, is explained in the following. Addition: if we have two surds, say square root 5 plus square root 5. They are the same surds, they will be added it and they are equal to 2 into square root 5. Similarly, if you have 4 into square root 3 minus 2 into square root 3, surds are same but their coefficient are different, so 4 minus 2 is equal to 2 into square root of 3, or in other words you can say square root 3 is common and inside the bracket we have 4 minus 2, it is 2 into square root 3, and see this 2 into square root 3, 2 into square root 3. So surds can be add and subtract. Same surds, similar surds can be added or subtracted into a single term is explained below. You can see the definition. And the multiplication and division, the next one is multiplication and division in the surds is also exist. We can multiply and divide surds of the same order by making use of the following laws of surds. When the surds are having same order, their radicand can be multiplied. For example, multiplication in surds, how it happen? If we have a number square root 7 multiplied by square root 2, see the surds are same, so they will be equal to 7 multiplied by 2, that is square root of 14. And if we have a cube root of 8 multiplied by cube root of 3, because the surds are same, the order of the surd is same, they can be written as cube root of 8 multiplied by 3, that is cube root of 24. And also when there is division, the surds can also be divided. For example, if we have a surd of 5 divided by a surd cube root of 2, and they can be written as 5 over 2 with their cube root. So these are the properties and the laws results we will use in exercise number 4.3, and I hope you understand that the properties and examples of the surds. And exercise number 4.3 we will start in the next lesson. Until then you will see the examples related to the surds, so you have must an idea to solve the exercise question. So exercise number example number 4.3.2, its example, and also the example on the page number 89 for your understanding and for your concept, you must solve them. Thank you so much. Allah Hafiz.